Resonance structures are fascinating structures because they allow us to see how molecules can stabilize their structural form due to the movement of electrons, in this case transforming from lone pairs to bonding pairs, and this allows their particular charge to be stabilized, rotating within the bond. That means pretty much the more you have those charges moved around, the better you have that particular structure to be stabilized. So in this particular scenario here, we're looking at this particular molecule here, and we want to show different ways by which it can stabilize a particular charge. And in this case here, the charge is going to be where? We're going to place a charge right here, and this is going to be a positive charge, and we're going to show how this positive charge can be stabilized in many ways. The stars here show that these structures here are not really stable. The first step here is that we're going to move the pi bond to become a pi bond here, and this is going to have our new pi bond to be shown here. But take note that our positive charge is going to move from this carbon over to this other carbon here. And so the next part here is that we're going to move this pi bond over to the other sigma bond, and so this here allows us to form this new structure where here we have our double bond. This positive charge is going to move over to this carbon, and while we have our double bond to now be here. The final one here is, after erasing them to show that they're stable, is the movement of this case here, lone pair on the oxygen to form a double bond between the carbon and the oxygen. And so this here is our new bond that is going to be formed, but take note that our positive charge is now going to be on the oxygen with one lone pair. There is another way of showing this, and this other way is by showing it in one shot. So this here, we're going to have the double bond coming over here, and this here comes over here, and now our new structure is not going to have the double bond here. It will now have the double bond here because of this movement, and then because of this movement, you're going to have your new double bond here. This is going to disappear, and finally you're going to have your new double bond here, and you're going to remove your lone pair. And so now you have a positive charge in this particular structure, and this here you can remove your positive charge as well right here. Take note that in order for this to be a resonance structure, you have to show the bracket. And the final part here is this. We need to be able to show the process in the reverse way. And so we show the opposite direction. We bring this back to a lone pair, and that gets us back to this. This here becomes a double bond. This becomes a double bond here, and we're going to have this here being generated. So interesting to see how resonance occurs when it comes to stabilizing a molecule in organic chemistry.